My name is Adam Boss, and this is my Physics 2212, Lab 3, the magnetic field of a bar magnet. So, the introduction for this lab. The purpose of this lab was to measure the magnetic field of a bar magnet using a magnetometer on my phone, on axis, off axis, and perpendicular to the bar magnet. Now, some important principles and formulas for this experiment include the Biot-Savart law, which states that the magnetic field is proportional to a constant mu naught times the cross product of a certain charge times the velocity of the charge. And you also have the magnetic dipole moment. The formulas for when it is on axis and perpendicular to the bar magnet. So for the experiment itself, the materials needed were a magnetometer app that was used on my iPhone and a ruler as well. The iPhone app was prepped and placed on a ruler, and the magnet was placed on the side of the ruler, and the iPhone recorded measurements of the magnetic field as the magnet moved through the ruler. Thus, the relationship between the distance could be found. The system for such an experiment would be the magnet, and the surroundings would be everything else, such as the Earth and the magnetic field that it makes, and those that interact with the magnet itself, specifically the magnetometer within the iPhone that's able to detect the magnetic field. Now, some important models and formula for this experiment. The first one is a calculation for an off-axis calculation, where the magnetic field is the product of mu naught divided by 4 pi times 1 over the distance cubed. And this is the term on the right is a cross dot product between the magnetic field and the position vector, and it is used for when the magnetic field being measured is off axis from the bar magnet. So it's not on axis, nor is it perpendicular to the bar magnet. Additionally, for the magnitude of the bar magnet, you have some constant k to the distance n, and this k will remain constant throughout the experiment. So really n could be plotted by measuring r versus the magnitude of the bar magnet, as shown below by taking the natural log of that value. You get the natural log of k, which is some constant, so it doesn't matter, plus n natural log of r, so you can use the slope of the relationship of the two to find n specifically. Now for the results, the glow script got 5e to the negative 5, while the experimental got 4.38 e to the negative 5, so somewhat similar results. There are some inconsistencies. For example, in the experimental, it may not have been exactly on the north, so the magnetic field of Earth could have contributed. The magnetometer itself could have been faulty within the app, and the magnet's distance could have been hard to register on the ruler due to errors in precision, specifically with the ruler. So here's my glow script code. This is the first part of the code, and this is the later half, which was used to determine or to map the situation of a bar magnet between distance, hypothetically, without considering the magnetic field due to Earth. And so the what ifs. What if we did not measure or compensate for the true north? The results would be different because we did not compensate for the magnetic field due to Earth, which would make some cause for some inaccuracies in the work. And if it were two magnets stacked next to each other, they'd have a similar direction, but it'd be twice the magnitude, assuming that the distance between the two magnets is negligible. Thank you.